Hello, geometry folks. Today we're going to be starting a new unit called Unit 4, and that is triangles and congruence. So, of course, the first thing we're going to talk about is triangles and angles. So what you'll need today are your notes, the foldables, there should be 2 of them, and then a pen or pencil or a calculator. So with that, let's get started. You do not need to write this down, but let's just first recall the definition of a triangle, and I'm sure all of you know this, but a triangle is a shape with 3 angles and 3 sides. Next, we're going to learn about how to classify a triangle, and to do this, we're going to use the first foldable, which looks like this, and it's already filled out for you, so there's nothing that we have to do to fill in the foldable, but I'm sure you've all seen these words before: equilateral, isosceles, scalene, obtuse, right, acute, equal, angular, and if you just open those flaps, it'll have the definition and an example on the inside. So go through that on your own because that's review. So you don't have to write this example down in your notes, but I would like you to just listen through it with me to kind of see where we're going today. So first, let's plot our 3 points. We're going to draw the triangle ABC. A is at 0, B is at 3, 3, and C is at negative 3, 3. So this is triangle A, B, C. So when we classify triangles, we need to classify them like that foldable was telling us, which is by angle and side. So first, when we're looking for angles and sides, we want to see if any of the sides are congruent, and we want to see if any of the angles are right, obtuse, acute, or equal. So with that, we could try to figure out which sides, like AC, AB, or CB, are congruent by using the distance formula. Remember that long distance formula is like D is the square root of x1 minus x2 squared plus y1 minus y2 squared. Well, I'm not going to go through that because we've already covered that. But if we were to do that for each of the 3 sides, the distance formula, we would find that the side AC and AB are congruent, but they're not congruent to CB. So that tells us that the triangle is going to be isosceles. But now we have to classify it by the angle. And so far we have all acute angles, but we may have angle A may be a right angle. It kind of looks like it. So in order to double check that, we would have to check the slopes of these lines if the line segments continued, AC and AB. So the slope of the line AC is down 3, to the right 3. So the slope is a negative 1. And then if we were to find the slope of AB, it would be down 3, so negative 3 over to the left 3 is negative 3, which turns to a positive 1. Is negative 1 and positive 1 opposite? Are they opposite reciprocals of each other? Yes, they are, which means that these 2 lines, AC and AB, are perpendicular to each other, which in turn means that the angle A is a right angle. So does it have a right angle? Yes, it does. So this triangle is a right isosceles triangle, and that's what we're going to do today when we classify triangles. Along with classifying triangles, today we're going to learn facts about triangles. So 3 facts that we need to learn are the triangle sum theorem, the exterior angle theorem, and the other helpful theorems. So if you want to grab this foldable, that's what we'll do next. So if we open up that first flap, the triangle sum theorem, this would be the inside, and the definition is the sum of the measures of the angles in a triangle is 180 degrees. So what we're saying is the measure of angle A plus the measure of angle C plus the measure of angle B is equal to 180 degrees. That's something that you guys are probably pretty familiar with. And we've looked at some examples before, but let's look at this example in the foldable. We're asking for what the measure of angle G is. So in order to find it, we'd take 180, and that would equal 115 plus 35 plus the measure of angle G. So in order to do that, 115 plus 35 is 150, and we just carry down everything else, 180. In order to solve for the measure of angle G, subtract both sides by 150, and the measure of angle G then is 30 degrees. Before we define the exterior angle theorem, we should define what an exterior angle is. And an exterior angle is an angle outside of a triangle. There can be angles outside of a triangle because we can have rays as a side of a triangle. So interior angles are obviously the angles that are all inside of the triangle. So exterior then would be this angle. And you don't have to write that down. I just wanted to explain it really quick. So let's open that middle flap exterior angle theorem. The definition is the measure of an exterior angle of a triangle equals the sum of the measures of the non-adjacent interior angles. So what that means is if we look at the diagram below our definition, we're saying the measure of angle 1, that's our exterior angle, is equal to the sum of the two non-adjacent interior angles. So it's equal to the sum of the measure of angle A plus the measure of angle B. Angle A and angle B are the two angles that are not adjacent to angle 1. C is the only angle that is adjacent to angle 1. So we're saying that the exterior angle is equal to, the measure of the exterior angle is equal to the sum of the two non-adjacent interior angles. So let's look at an example of how we could set up an equation with that. We're saying 2x plus 10, because that's the exterior angle, is equal to two non-adjacent interior angles, which would be the angle that measures x degrees and the angle that measures 65 degrees. So we're saying 2x plus 10 equals x plus 65. So from here, it's just a simple algebraic equation. We're going to subtract x from both sides, get x plus 10 is equal to 65. Subtract 10 from both sides. And now we have x is equal to 55 degrees. And that's all we needed to find. Let's open up that last flap, some other helpful hints or other helpful theorems for triangles. The first one is if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. The second theorem is each angle of an equilateral triangle has a measure of 60 degrees because every equilateral triangle is also equal angular. So if an equilateral triangle has the same length of all the sides, it also has the same measure of each angle, and 180 divided by 3 is 60. And let's look at our third theorem. In a triangle, there can be at most one right angle or one obtuse angle. And if you think about it, that just makes sense because we only have 180 degrees to work with in order to form a triangle. Having two right angles in a triangle adds up to 180, but then it wouldn't look like a triangle because there's no way to connect the two lines that are going straight up. And then if you have more than two obtuse angles, you would go over 180 degrees. So there can only be one right or one obtuse angle in a triangle. And then last but not least, our fourth theorem is the acute angles of a right triangle are complementary. And that makes sense, right? Because if we have a right triangle, one of the angles is 90 degrees, well, 180 minus 90 is 90. So the last two angles that aren't right have to add up to 90 degrees. So let's look at an example using one of these theorems. They're asking us to find the measures of the acute angles in a right triangle ABC. So we're going to use the last theorem that we talked about. So they're saying that if the measure of angle A is x minus 6 and the measure of angle B is 2x, those are our two acute angles that are going to be complementary because angle C is 90 degrees. It's a right angle. So we're going to have the measure of angle A plus the measure of angle B is equal to 90. So x minus 6 plus 2x is equal to 90 degrees. Combine like terms, 2x plus x is 3x minus 6 is equal to 90 degrees. Add 6 to both sides. We get 3x is equal to 96 and divide by 3. So x then is 32. But they didn't ask us to find x. They asked us to find the measure of angle A and the measure of angle B. So the measure of angle A then would be 32 minus 6, which is just 26 degrees. And the measure of angle B is 2 times x, which would then be 2 times 32, which is 64 degrees. Is 26 plus 64 90 degrees? Yes, it is. So we know that because we checked our work. We have one more example that's not in a foldable for you. So if you want to take a second to pause the video so that you can draw this picture in and write the directions, pause the video and do that for yourself. But we're trying to find the value of x and y. So we are going to use the knowledge that we learned today and the knowledge from our previous units. So first we're going to notice that these two lines, because of these triangles right here, are showing us that these two lines are parallel. So we're going to have some angles that are congruent because of our parallel lines. Remember those theorems? Like interior angles. If we looked at this transversal from the parallel lines, we know that the measure of the angle that's 43, the angle that measures 43 degrees is going to be congruent to the measure of the angle that's x degrees. So those are alternate interior angles if we look at this transversal with those two parallel lines. So right off the bat, we know that x is 43, or x degrees is 43 degrees. So another thing we're going to notice is that the angle that measures 75 degrees is an exterior angle. If we think back to our foldable of the exterior angle theorem, we're saying that the sum of 43 and y is equal to 75. So let's set that up. 43 plus y is equal to 75. So now all I have to do to solve for y is subtract 43 from both sides. So y is equal to 32 degrees, or y degrees is equal to 32 degrees. I want to thank you all for watching the video, and I think this last example is a good example of what we're going to be doing in this unit, how we're not just using triangle knowledge anymore to find x and y values. We're going to be building on the last 2 units or 3 units that we've been working with. So thank you and have a good night.